I actually just went and checked on your YouTube page. I don't know if it was deleted by accident or if it's under a different label, but there's one video in the playlist that says deleted, and then the other ones are like the curvature lecture and then your most recent lecture. So I'm not sure if there was a problem with that or if I just can't find it. But
So I think the deleted one. Oh, one sec. Maybe this one is just being uploaded now. 1 second. Yeah, so the review for exam 2 is being uploaded, and then there's like arc length and curvature, and I did delete one of those, but then I re-uploaded it, so that should be okay.
okay.
Yeah. So also a few of you asked me, have been pointing out that archive does not give you the correct solution if you approximate the solution, which I guess is a mistake from their perspective, but I would recommend that you just put in the correct solution, the exact solution every time with the square roots and the pi and whatever, just so that it's easier and I don't have to go and change everyone's grade. Okay, so we had z is equal to x squared minus y squared. So if, let's imagine that, let's start with x is equal to 0. So if x is equal to 0, we have z is equal to negative y squared, and we are in the so this would be y and this would be z. So we would have a parabola that looks something like this. Now let's try y is equal to 0. Then we have z is equal to x squared. So then we would have x and z, and we would have something that looks like that. And then for z is equal to 0, so then z is equal to 0, we would have x squared minus y squared is equal to 0. So x is equal to y, but plus or minus, and we would have two curves, two lines, sorry, like that. Any questions about this so far? And so we would have a hyperbolic paraboloid. Two parabolas, one hyperbola, and that would be the answer. Okay, let's go on to part B. So for part B, we have negative x squared plus y squared plus z squared, negative x squared plus y squared plus z squared is equal to negative 1. Okay, so again, if we take x is equal to 0, we get y squared plus z squared is equal to negative 1. And then we would have that, yeah, so this would not really appear because you cannot really have this being equal to negative 1. So then if we set y is equal to 0, we get negative x squared plus z squared is equal to negative 1. And this would be two hyperbolas. And we can, so here is going to be our x, here is going to be our z. So if z is 0, then negative x squared is equal to negative 1. So that would mean that this would be 1 and this would be negative 1 in terms of x. And then for z is equal to 0, we would have negative x squared plus y squared is equal to negative 1. So again, we would have two hyperbolas. And again, this would be 1 and negative 1. And so this whole thing together would be a hyperboloid of two sheets. And yeah. Any questions? Okay. So the next question asks us, consider the parabolic cylinder y is equal to z squared minus 1 and the plane that parameterized the curve intersecting the above surface is. So let's start with that. So y is equal to z squared minus 1. Y is equal to z squared minus 1. And the plane x plus y, 2y is equal to 4x plus 2y is equal to 4. Okay, so in these type of situations, it's sometimes just beneficial to see what would be the most complicated variable to deal with, which over here would be the z because it's being squared. And we can try to figure out now what our parameterization would be, but let's just set z is equal to t. So this would be, okay, so then y would be equal to t squared minus 1, and that would go here. And x is equal to 4 minus 2y, which would be equal to 4 minus 2t squared minus 2, which would be equal to 2 minus 2t squared. Sorry, 1 second.
Wouldn't it be plus 2?
1 second. This would be that. Oh, because this is negative. Yeah. 6.
Yeah, I got 6 minus 2t squared.
Oh yeah, perfect, thanks. So 6 minus 2t squared. So that would be our curve. So r of t is equal to 6 minus 2t squared, t squared minus 1, and t. Okay, so that would be the parameterization of our curve. So now they ask us to find, find the points at which the curve intersect the plane x plus 3y plus 4z is equal to 0. X plus 3y plus 4z is equal to 0, and we already did this in the classes before the first exam. We just take the x, the y, and the z from here and we plug it in. So that would give us 6 minus 2t squared plus 3t squared minus 3 plus 4t is equal to 0. Okay, so that tells us that this and that would give us t squared, and then we would get plus 4t, and then we would get from negative that plus 3 is equal to 0. And so from here we're going to get that t plus 3, t plus 1 is equal to 0. So t is equal to -3 and t is equal to -1. And so the two places where we intersect our plane are going to be r of -3 and r of -1. Any questions?
So do we plug that back into R of t?
Yeah. So this would be, I'll just do the -1. So that would be 6 minus 2, which would be 4. And then the other one would be 0, and then the other one would be -1. So that would be 1 point, and then you can plug in the other one. Any questions? Okay. So let's go on to the next problem. Consider the curve given by this. Well, this is actually interesting because the last exam 1 has more problems than exam 2. And I think there's also a third exam posted, so I would recommend that you all try to do that at some point by yourselves to see how that works out. But okay, consider the curve given by r of t is equal to t squared, t to the third over 3, and 2t. So r of t is equal to t squared, t cubed over 3, and 2t. And we want find the arc length of the part of the curve between the point 0, 0, 0 and 9, 9, 6. So 0, 0, 0 to 9, 9, 6. So the first thing that we need to figure out is what t's give you this. So if you have 0 over here, the first one would probably be 0. So t is equal to 0, 2. And then the other one would be 3. Okay. Right. Okay, so now that we have that, we can find the arc length. So we know that the arc length would be the integral from 0 to 3 of the magnitude of r prime of t dt, which would be the integral from 0 to 3 of the square root of 2t squared plus, okay, the 3 comes down, so you get and cancels t squared but squared, so t to the 4th plus 2 squared. dt. Okay, now this is going to give us, so again, we'd have the integral from 0 to 3, and then we are going to have the square root of t squared plus 2 squared, question mark. Okay, t squared plus 2 times t squared plus 2. Yeah, that would be it. Okay, so that would be that, which would give us the integral from 0 to 3 of t squared plus 2 dt, which would give us integral 0, 3 t to the third over 3 plus 2t. And that would be the zeros and nothing, and 3 cancel. So that would be 9 plus 6. Okay, any questions? Okay, so going back here, calculate the curvature of the curve at this point. So the curvature we know is the magnitude of r double prime of t cross r prime of t over the magnitude of r prime of t cubed. So we need to figure out what r prime of t is. R prime of t is going to be equal to 2t t squared and 2t squared and 2. And we're looking for the curvature at the point 996. Oh, which would be t is equal to 3. So t prime at 3, that's going to be equal to 6, 9, 2. Okay, t double prime is equal to 2, 2t, and 0. So t double prime at 3 is going to be equal to 2, 6, 0. Okay, so now t prime at 3 cross t double prime at 3 is going to be equal to I, J, K, 6, 9, 2, 2, 6, 0, which is going to be equal to, okay, we're going to have I, 0 times negative 12 minus J, 0 times minus plus 4 plus K, 36 minus 18. So this is going to give us negative 12, 4, and 18. Okay, so now the magnitude of this is going to be equal to the square root of 12 squared plus 4 squared plus 8 squared. Okay. So now the next thing we want to know is what is the magnitude?
It would be 18 squared, not 8 squared.
Oh, sorry, 18. Okay. So now the magnitude of r prime 3 is going to be equal to 6 squared plus 9 squared plus 2 squared, so the square root 6 squared plus 9 squared plus 2 squared. Okay, so then you take this and you divide it by this, and that would give you t is going to be equal to, oh, you need to cube it also, square root of 12 squared plus 4 squared plus 18 squared over square root of 6 squared plus 9 squared plus 4 cubed. Okay, any questions? Okay. So the next problem, they tell us that the particle A has position function that, while particle B has velocity function that, an initial position that. Do the particles collide at which times and at what points? Okay, so the first thing is we want to find the position for this one. So V2 is going to be equal to 2 3t squared and pi sine pi t. Pi sine pi t. Okay, and the initial positions 2, 2, and 3. V2, 0 this is t, is going to be equal to 2, 2, 2, 3. Okay, so R2 of t is going to be the antiderivative of this, so that would be 2t plus c1 t cubed plus c2, and cosine negative cosine of pi t. Plus C3. Okay, now RT0 is going to be equal to, so this would be C1, C2, and one second. Okay, and over here we would have, okay, cosine negative cosine of pi, that would be 1 plus C3. This is equal to 2, 2, and 3. So R2 of t is going to be equal to 2t plus 2, t cubed plus 2, and negative, okay, so here we have 1 plus this is equal to 3, is equal to 3, yeah. So yeah, 2. So this would be negative cosine of pi t negative cosine of pi t plus 2.
Hey, real quick, can you explain how it's 1 plus C3? Because I kept getting -1 plus C3.
Yeah. So this is cosine of pi, right? So that would be this. And then there's a negative in front of it.
Yeah, I thought it would be cos of 0 if you're plugging 0 into t, though.
Oh, sorry, you're right. I thought I was doing 1. I apologize. So this would be negative. Okay, and this would be 4. And this over here. Yeah. Yeah, is this correct?
Yeah, I think so.
That looks right.
Okay, perfect. So now, yeah, so that's our R2. And then, so now we want to know if these two particles collide. So that would be R1 of t. Does R1 of t equal to R2 of t at some point? Which would mean that, okay, so that would mean that t squared is equal to 2t plus 2. Okay, and 10 is equal to t cubed plus 2, and t cubed minus 6, t cubed minus 6 is going to be equal to 4 minus cosine pi t. Okay, so if this is true, then let's see, what about this over here? Okay, so this would tell us that t cubed is equal to 8, which means t is equal to 2. But if t is equal to 2, that won't be equal. So yeah, these don't collide. No collision. Okay, any questions? So I think I'm gonna stop here. I'll post these videos, and I think there's one last exam, practice exam that's up. So I would recommend that you do it and look at the solutions to see if you got it right. If you have any questions, let me know. Okay, have a nice
Where
day.
can you find that that exam 3 that you keep saying?
So I think, let me check. It should be on the same page, the PSU 230. You look at sample exams. Yeah, so exam 3 sample problems. Oh, maybe 1 second. They might be. Oh, this is exam 3. Okay, I apologize. So yeah, there isn't another exam. Okay, yeah, I apologize. Any other questions?
So we can take this anytime tomorrow, right?
So I think there's 3 different exams, 3 different slots. So you have to pay attention to those 3 different, but you can take any one of those 3, yeah. Okay, have a nice day.